Hello, my name is Naya Patel. My student ID is 1014163336, and hereby I'm presenting you my assignment 3 for COMP3132 Machine Learning. So in this assignment, I will show some concepts about convolution 2D kernel and neural network. So here as we can see, this is part A. I have pre-run all the cells. So these are all the pre-run and with the output. So these are the output after running this cell. So the first question was based on kernel's representation on the above image. Create a kernel to detect 45-degree lines using convolution. So here is the code. I have added that 45-degree lines. And after running this code, this is my output. The same thing, it's asking me to add 135-degree. So as we can see, this is my final output after running this cell. Next up, it's asking me to apply the following kernel to my image, this one, and to plot the output. So after adding that, this is my output 1, the second one, and this is my output 3. Next up is part B. So I have also run this all cells previously. So as we can see, these are some following outputs of those. So just look at this graph once. Next up, the question is, does this network present signs of overfitting, and if so, in which epoch? So as we know, overfitting occurs when training accuracy, it keeps increasing while the validation accuracy keeps decreasing. So in this, yes, we see overfitting. So it says in which epoch. So as we can see over here, the training accuracy keeps increasing, but the validation accuracy keeps increasing till here, and now it starts decreasing. So this point is between 10 to 15. So overfitting starts around 10 to 15 epochs. Next up, it's asked me that how many layers this model has and that type. So apparently this model has 4 different types, but there are 2 dense layers. So there are total 5 layers in this model and 4 types of layer. The first one is Convo 2D, and it's a layer with 32 filters, kernel size of 3.3. Next up is Max Pooling 2D. It's a layer with pool size of 2.2. The other one is a fluttering layer to convert the output of the previous layer into 1D array. Next is a dense, which is connected with layer with 128 units and activation. Next up is another dense layer. So this one is the output layer, and it is connected layer with 10 units and softmax activation. Next up, it asks me the purpose of each layer. So as we know, there are total 5 layers. So first one is Convo 2D. It extracts features from the input image using the learnable filters. The next one is Max Pooling 2D. It reduces spatial dimension of the feature maps and decreases the number of parameters. Next up is Flatten. It converts the multidimensional feature maps into a single vector. So it converts like 2D to 1D. Next up is Dense. It's connected layer that learns relationship between extracted feature and output classes. And the other dense layer is the output layer. So it produces the final classification probability for each of the 10 classes using the softmax activation function. So the next one, it asked me to add more layer and rerun my model. So let's see. So here, this is my code. I have added this layer in there. So after running this code, this is my curve, like the graph. So now the question is, compare the results between original model, which was the previous one, and the bigger model where I have added extra layer. So the main, like we can see, is the bigger model is achieving more accuracy than the original model. So it says that complexity is added in this layer, the bigger one. Then it was in the previous one, which was the original one. Next up is the bigger model converges slower than the original model. So it is like earlier when the curve was starting from, let's say, 5, here it's starting from 10. So it's taking more epochs to reach a similar layer of performance. So this is expected due to increased number of parameters. Next up is a bigger model shows sign of overfitting with a larger gap between training and validation accuracy. So as we can see in this one, so there is a quite more difference than the previous one, which was this one. So this is evident that this two they have overfitting but at different levels, like different gap. The original model extracted simpler features, while the bigger model added convolution layers, captured a richer representation of images. So, as I mentioned previously, so we have added more complexity in the bigger one. So, the representation of images is more richer than the previous one. The original model had lower capacity, reducing the risk of overfitting, but as there's more in the new one, increased capacity allowed it to learn more complex patterns. Next up is the bigger model required more computational resources and training time compared to original model. So as I know, when I run those cells, original model took approximately 30 minutes, while the bigger model it took around 1 hour to complete. So it's taking more time and more resources. So while the earlier one, which was the original one, it was easy to interpret, this one has more complexity. So the poses challenges for understanding. So like as there's complexity, it's there are more challenges in this. Next up is add a drop-off layer to your model and run it. So as we can see here, I have added the dropout layer. After running this is my final graph. Now it asks me that what is the purpose of a dropout layer and how it works. So the main purpose of dropout layer is to prevent overfitting in neutral networks. So as we know, overfitting happens when training accuracy keeps increasing while the validation accuracy keep decreasing. So drop off layer helps the model to generalize better to the new data by making it less reliant on a single neuron. So I can explain this with an example. So let's say we are working in a team. So in this team there's a leader who do all the work, most of the work, let's say. So if the leader is somehow not able to come to the meeting today, so the team lags behind the task which the leader was doing as they were dependent on him. So what um, dropout do is it will let the leader take breaks in the meantime when the whole team is discussing. So when the leader goes on the break, the whole team is responsible to divide the leader's work among themselves. So by any chance, if the leader is not present, the team can handle that task. So exactly how the dropout layer works. So it forces the members to learn how to handle difficult tasks and become more independent so that the whole team becomes more resilient and adaptable. So that's pretty much from my side for this assignment 3.